Welcome to physics class. Let us start today's discussion with the question asked in previous video. First question, speed of light in water is 2.25 into 10 raised to power 8 meter per second. What is the refractive index of water? Speed of light in water is 2.25 into 10 raised to power 8 meter per second. Speed of light in air, we know that is represented by c, which is 3 into 10 raised to power 8 meter per second. Now we know that NW, that is refractive index of water, but we have to calculate, that is c upon VW. C is speed of light in air represented by c, and VW, that is speed of light in water represented by VW. Let us fill the values. Let us calculate refractive index of water. Value of C, 3 into 10 raised to power 8, and that of VW, 2.25 into 10 raised to power 8. Now NW, which is equal to, we'll remove the decimal point, it will become 300 into 10 raised to power 8 upon 225 into 10 raised to power 8. And by solving this, answer is 1.33. Question 2. What is the unit of refractive index? Since refractive index is the ratio of velocities, hence it is unitless. Today's topic, refraction by spherical lenses. Lenses are used in many devices in our daily life. Lenses are used in camera. You're able to see the lens here. Binoculars having lenses. And in case of the spectacles used for correcting certain eye defects. Here we will discuss about lenses in detail. First, let us define a lens. A lens is a transparent medium bounded by two refracting surfaces. Either both the surfaces of the lenses are spherical or at least one surface is spherical. Types of spherical lenses. There are two types of lenses. One is convex, second one is concave. We will discuss them one by one. First of all, convex lens. A convex lens is thicker at the middle but thinner at the edges. Likewise, it is thinner at the edges, both the edges, but thick at the middle. You can see. I'll show you another lens. Again, it is convex, but it is less thicker than the first one, and the third one, which is again lesser thicker than second and first one, but thin at the edges. All these are convex lenses. And the working of the lenses, both type of lenses are based on the refraction of light rays when they pass through it. Now second one, convex lens. A convex lens is thinner at the middle but thicker at the edges. The refracting surfaces of the concave lens are depressed inward at the center. At the edges it is thick, but they are thinner at the center. Now let us define some important terms related to the refraction through these spherical lenses. Centers of curvature. Centers of curvature of a spherical lens are defined as the centers of spherical surfaces from which lens is formed. It is clear from the pic. C1 and C2 are centers of curvature of two spherical surfaces. Principal axis. It is an imaginary line passing through the center of curvature C1 and C2. Principal axis is perpendicular to both the surfaces of lens. Optical center. If the lens is thin and the radii of curvature of two refracting surfaces are equal, then the geometrical center of the lens is called its optical center. It is represented by O. Radius of curvature. The two spherical refracting surfaces of which the lens is made up of have their own radii of curvature which may either equal or unequal. In the upcoming analysis of the lenses, we shall consider the surfaces with equal radii of curvatures. Aperture. The part of the lens from which refraction of light takes place is known as aperture of the lens. Principal foci of a lens. There are two principal focus on either side of a lens which are known as principal foci of the lens. First principal focus of a lens represented by f1. It is a point on the principal axis of a lens from which light rays coming or appears to coming become parallel after refracting from the lens. It is represented by f1. First principal focus of lens, convex and concave, are shown in the figure. Second principal focus of lens f2. It is a point on the principal axis of a lens where a beam of parallel rays meet or appears to meet after refraction from the lens. It is represented by f2. And second principal focus of convex lens and concave lenses are shown in the diagram. Focal length. It is the distance between the principal focus and the optical center of a lens. It is represented by a small f. Since there are two principal foci, hence there are two focal lengths of a lens. First principal focal length. The distance between the first principal focus of a lens and its optical center is known as first principal focal length. OF1 is the first principal focal length represented by f1. Second principal focal length. The distance between the second principal focus and the optical center of a lens is known as second principal focal length. OF2 is the second principal focal length represented by f2. When both the refracting surfaces have equal radii of curvature, first principal focal length is equal to the second principal focal length. Hence, f1 equal to f2. Converging lens. Convex lens is known as converging lens because it converges all the light rays falling on it parallel to the principal axis at a single point. This diagram shows convex lens converging the light rays at focus f2. In this activity, I'll use the tile and convex lens. I'll try to focus the sunlight on the tile in the form of a sharp spot. I'll adjust the distance of this lens and you'll be able to see the spot. Diverging lens. Concave lens is known as a diverging lens because it diverges all the light rays falling on it parallel to the principal axis as shown in diagram. To discuss the formation of image by a lens, let us discuss rules needed to draw the ray diagram. Rule 1. When a light ray is incident on the optical center of a convex lens, then it passes through the lens undeviated. Rule 2. When a ray of light falls on lens parallel to principal axis, then it passes through the focus of lens after refraction. Rule 3. When a ray of light is incident on the lens through its focus, then the ray becomes parallel to the principal axis after refraction to the lens. Now we will discuss the rules for the formation of image by a concave lens. Rule 1. A light ray traveling parallel to the principal axis appears to be coming from the principal focus f2 of the concave lens after refracting from lens. Rule 2. A ray of light directed toward the focus of a concave lens becomes parallel after refracting through the lens. Rule 3. A ray of light passing through the optical center of a lens travels undeviated through the lens as shown in the diagram. You have to draw the ray diagrams given and write down the important points, rules, definitions in your notebook. Question 1. In the given ray diagram, what type of lens or mirror is placed in the box? Question 2. What are the conditions in which no refraction of light ray entering from one medium into another takes place? You have to find out the answers. I'll discuss the answers in my next video.
Thanks for watching. Like, share and subscribe the channel.